If you don't have a piece of paper out in front of you, please pause this video and go get one so that you can take down some notes. We're going to talk about simplifying radicals. This is something that we've done before, but when we talked about radicals, we simply talked about square roots. So for example, we would simplify the square root of 4, and that would give us 2. Or maybe we would simplify the square root of 20, and since 20 is not a perfect square, we would break that down into a perfect square and a non-perfect square factor so that we could take the square root of the perfect square, and then we would just leave the other factor underneath the square root. Another way that we did the square root of 20, if you couldn't identify what the perfect square was, is that we would take the number 20 and we would take and find all the prime factors. Since it's even, start by dividing by 2. Since 10 is even, divide by 2 again. And then since we were taking the square root, we would be looking for pairs of numbers. So I see a pair of 2's here. So that means that would give me a 2 out in front of my radical. And then I would be left with this factor that doesn't have a pair. So it would give me the square root of 5. So this answer and this answer are the same. So it was just a different way for us to do it. What we're going to be talking about now is things that are not square roots, but maybe cube roots and fourth roots and fifth roots. So the first thing we need to talk about is what is everything called? So if you see a number in here inside the little check mark portion of this symbol, this is what we call the index. Our index when we have a square root is 2. Because it's a square root. It's understood to be a square root. But if you see a 3 in here, then we know it's a cube root. If you see a 4 in here, we know it's a fourth root. This underneath here, whatever it may be, an expression, it might be a quantity, this is what we call the radicand. And then this symbol right here, I know we always call it a square root, but it's actually not called a square root, it's called a radical. We usually just call it a square root because that's what we're used to dealing with. So what we're going to see today are ones where the index is something other than a 2. So maybe we have the cube root of 8. So what we need to do is we need to find a number that when you multiply times itself 3 times, you get an 8. And I know that 8 equals 2 times 2 times 2. So the cube root of 8 is just the number 2. If I tried to take the cube root of 81, well, I would try to think about numbers that multiply into 81, maybe a perfect cube, but a lot of us aren't very good at our perfect cubes or as good at those as we are as our perfect squares. So a way that we do this is just by going and using our factor tree. So I would take my 81 and I would just try to break it down. So 81 is not even, so you can't divide it by 2, so just go ahead and divide it by the next prime number, which is 3. 81 divided by 3 is going to give you 27. And you want to keep dividing by 3 until you can't divide by 3 anymore. So 3 goes into 27 9 times, and then 9 is 3 and 3. Now, when we're doing square roots, we make our factor tree and we pick a pair of numbers because we're taking a square root. We're looking for pairs. Whenever we take a cube root, this number here will tell you how many of these over here to group together. So since we're looking for a cube root, I'm going to grab 3 of these at one time. And that's what comes out front. And then anything that's left over, so that 3, I would need 2 more 3's to be able to let it come out of the cube root. But since it's just a 3, it has to just tack on to the end. So basically what you're doing is you're doing the factor tree method that we learned about our square roots, but the index will tell you how many of these numbers from your factor tree to group together at once. So this worksheet is the one that's attached to your classwork today. So I'm just going to go through a few of these, and if you haven't printed this off yet, go ahead and pause the video and print it off so you can follow along. Okay, so I'm looking at the cube root of 448. So 448, I don't know if that's a perfect cube or not off the top of my head, so I'm just going to go ahead and make a factor tree. So you go over to the side, take your 448, and you just start dividing by all your prime numbers. If it's even, you always want to go ahead and start with 2. So if I take 448 and I divide it by 2, I'm going to get 224. 224 is still even, so I'm going to go ahead and divide by 2 again. 112. And then 112 is still even, so I'm going to divide by 2 again, and I get 56. 56 is still even, so divide by 2 again. 2 and 28. Still even, so that's going to be 2 and 14. That's still even, so that's going to be 2 and 7. 7's a prime number. You can't break it down anymore. Okay, so pay attention here to my index. I'm looking for a perfect cube, so I want to grab 3 numbers at a time. I want to group 3 at a time. So I just like to start from the top of the tree. So 1, 2, 3. There's 3 2s here. So that means 1 2 can come out front. There are 3 more 2s here. So another 2 can come out front. And then we have this 7 that can't pair up with anything. So this has to stay underneath your cube root. So you always want to use the same symbol as you see here, the cube root of 7. And then if you have more than one number out here, then you just go ahead and multiply together. So 2 times 2 gives me 4. So 4 cube roots of 7 is your answer. So these are done with the factor tree usually because it just is a really good way to keep yourself organized. Let's try another one. So right here, I'm looking at the 4th root of 405. So you want to take your 405, go over to the side, and just start dividing it. Now 405 is not even, so we're not going to start with 2 this time. Maybe we try to divide it by 3 because that's the next prime number. 3 goes into 405 135 times. And then you see if that's also divisible by 3, and it is. 3 and 45. 45 divided by 3. You're going to keep going until you can't divide by 3 anymore. 15 is divisible by 3. 3 and 5. Okay, so remember in the last problem, you want to look at your index before you start circling numbers over here because this will tell you how many to group together at once. I'm looking for a 4th root. So I'm going to go over to my factor tree and I'm going to look for 4 numbers that match. So I have 4 3s and then I have this 5. So then your final answer, 4 3s means 1 3 in front of the radical, and then the 5 has to stay under. So it's 3 times the 4th root of 5. Okay, let's try one that has a negative in it. Well, that didn't work. Now I know we did square roots before, and when we tried to take the square root of a negative, it turned out to be an imaginary number. That's not the case when you're dealing with cube roots or fifth roots of negative numbers. It only happens when you're dealing with even roots of negative numbers. There we go. So since my index here is odd, you actually can take the cube root of a negative number. So you're just going to go over to your factor tree, negative 128. So 128 is even. So I'm going to start, if this is a negative number here, start with a negative 2. So negative 2 goes into 128. It's going to be positive 64 times. Now 64 is even, so we're going to keep dividing that. 2 and 32, 2 and 16, 2 and 8, and 2 and 4. Okay, so we are taking cube root. So you're going to grab 3 of the numbers. Take one of the negatives with you, because this negative, you actually can just bring it out front, because the cube root, it's almost like saying the cube root of negative 1 times the cube root of 128. So the cube root of negative 1 is negative 1. And then the cube root of 128, well, you can just grab 3 of these 2's and bring one of them out front. And then, whoops, I forgot to divide this one more time down here. Sorry about that. This 4 goes 2 and 2. Okay, and then we have another pair of, or another trio of 2's. So another 2 can come out front here. And then we have this 2 here that doesn't have a partner. So it has to stay underneath our cube root of 2. Okay, so you don't necessarily have to, bring the negative over here when you're doing your factor tree if you understand that when you take an odd root of a negative number, then your final answer is just going to be negative. Okay, so negative 1 times 2 times 2, this is negative 4, and then cube roots of 2. Okay, so negative underneath an odd index, that can be done. Okay, let me see. Let's try one more. So let's look at this one here. Here's another negative. So I have the cube root of negative 32. It's supposed to be a cube root. So you're going to go over to the side and you want to make your factor tree. So, and like I said, if you don't want to worry about this negative when you're doing your factor tree over here, just think about this as the cube root of negative 1 times the cube root of 32. The cube root of negative 1 is negative 1 times, and then we're going to figure this out. So if I take 32, it's even, we're going to divide by 2. Keep dividing by 2 until you can't do it anymore. And then since it's a cube root, we want to grab 3 at a time. So I'm going to grab 3 2's. So that means 1 2 can come out. And then I have this 2 and this 2 that have to stay underneath the radical, because in order for it to come out from underneath the radical, you would need 3 of them because it's a cube root. So this has to stay underneath, and you have 2 of them, so under the radical is 2 times 2. And then you just go ahead and simplify this. Negative 1 times 2 is negative 2, and then 2 times 2 is 4, so it's the cube root of 4. All right, let me know if you have any questions, and please try the rest of the problems on this sheet. The answers are on the last page. Let me know if you get stuck.